Good evening, guys. So in yesterday class we discussed about the access list and object groups. So the topic of the day will be a ASP, and the second topic is about traceroute on firewall. So I'm starting first of all with ASP. So you need to understand about that first. Okay.
I have a class, so yeah.
Daniel, are you asking something?
No, sorry, one of my colleagues just came here. Sorry,
Okay.
I have a conversation.
So ASP stand for Accelerated Security Path. Okay. So what is that? What is the meaning of that? Accelerated security path. Okay. So actually this is giving you idea on ASA, how ASA can use fast path to forward the traffic. Okay. So this is used on ASA to give how ASA can use fast path to forward the traffic. Which traffic, guys? Which is already sent through the firewall. Okay, which is already sent through the firewall. Okay, let me explain you about that, what I am trying to say here. What is the meaning of already traffic sent, right? So try to understand, if I'm sending some traffic through firewall and same type of traffic is received on the firewall with same IP, same port number, same destination IP, same destination port number, so at that time ASA can use fast path instead of slow path, why? Because same traffic is passed through firewall, so why we want to forward the traffic through slow path? Okay. So we have firewall, and now here is the server, right? And here is the client. So client have 10.1 IP, 10.10 is gateway, 20.10 is here, and here is 20.2. Now just assume this client sends some data, so source IP is 10.1 and port number is random port number. Okay, this is random port number, and destination IP is 20.2 and the port number is 23. So this traffic is passed through the firewall, so firewall send the traffic, right? So maybe the same traffic is coming back to the firewall from the same client, so the client is sending same type of data. So that means which traffic is sent through the firewall, so firewall always forward through the slow path, but if this traffic is forwarded through the ASA for one time, so firewall can maintain here one table. Okay, like normally we use connection table, right? So just keep in mind connection table for now. So connection table have entry of this traffic, so second time firewall can just check the connection table and forward the traffic from exit interface. So this is my kind of which path, guys? Fast path. This is my fast path. Okay, let me understand you more better. Why? How? Okay, before moving on ASA, let's come to Cisco IOS router. Which router, guys? IS router, right? So on IS router, if you remember, router have two type of things. One is CPU, right? The processor, and the second thing is CEF. And what is CEF, guys? Cisco Express Forwarding. Cisco Express Forwarding. So are you aware about these two things, everyone? Any idea? Okay, let me tell you. Normally router have two things, one is the software and one is the hardware, right? So this is your router for now, and here is the CPU of the device, right? And this is your IO module. IO module means the interface line card. What is the meaning of IO module? Input and output module, which is interface line card, which is interface line card, right, where we connect the devices. So the traffic is coming on the device for the first time, and that traffic is coming to the CPU, and CPU forward the traffic from exit interface, right? So if this is going to happen with your IS router, so there can be thousands of packets. So every packet if passing through the CPU, so that will utilize your CPU a lot, right? So utilization will be increase of the CPU. So this is one problem. So now according to the after facing this problem, they introduce the concept of CEF. They introduce the concept of CEF. So CEF is like duplicate copy, or you can say like another component in device which handle all the user traffic. So normally CPU maintain your routing table. CPU maintain which table, guys? Routing table. So if every traffic is passing through the CPU, that means passing through the routing table, so that will utilize CPU utilization of the device, and this can cause problem for my hardware, right? Because we don't want to pass this type of traffic. Okay, so now we have here another component, that is CEF. So CEF is duplicate copy of routing table, that is known as forwarding table also. Okay, that is known as forwarding table. Forwarding table means which routes you have in routing table, the CPU of the router create a duplicate copy of same routes and give to your CEF. CEF means which available on your IO module, on line card of the device. Okay, so that means if any traffic is coming this time to my router, so router no need to involve the CPU anymore. So now router have another component CEF. So CEF have duplicate copy of routing table. So CEF can check every type of traffic through IO module directly without sending to CPU. So that means using the concept of CEF on IO module, we are giving fast path. What we are giving, guys? Fast path to the router, right? So router is getting fast path because of CEF concept, right? So that means if CEF is working on router, router is not going to use CPU just to forward the user traffic, Okay, now in similar case, if this is clear, let me tell you about ASP. What is ASP? So basically ASP is giving you fast path on Cisco firewall. Okay, ASP is giving fast path on Cisco ASA. Now there are three things that you need to know. The first thing is session management, right? Session management path. Okay, what is session management path? Session management path means which is used for the first time to pass the traffic through the firewall, like all the criteria checked by the firewall when firewall is forwarding the traffic, right? So like firewall check at that time, ASA checks routing table. Okay, like when ASA is forwarding data, ASA check routing table. After routing table, ASA check ACL. Maybe after ACL, ASA is going to check NAT. After NAT, ASA will check the inspection engine, right? Inspection of the traffic. So whenever traffic is passing through all these things through firewall, so that is slow path. So that is my session management path, guys. So session management path is actual slow path of the firewall. Why? Because whenever traffic is coming on firewall need to check everything. Okay, like traffic is coming on the firewall. So when traffic is coming on this interface of firewall always check the first thing is routing table, where the route is belong to, right? So if route is belong to the outside interface, so now next ASA is going to check is there any ACL on interface or not. The second thing, it will check the ACL. After that it will check the NAT, right? And after NAT, if you have any layer 7 inspection, like in yesterday class we did for telnet traffic, right, and for ICMP, so at that is also checked here. So whenever all these things are getting checked on the device, so that is taking slow path. So actual session management is like a slow path on firewall, because firewall is passing the traffic with every criteria. It can be ACL, NAT or inspection, right? So I think this is clear to everyone. What is session management path? Session management path is slow path of the firewall. That is slow path of the firewall. Okay. Or you can say inspection is not here maybe for every type of traffic, because this is part of another traffic. Okay. So we have second type of traffic here, that is control path. Control path, actually this is for layer 7 inspection. So whenever you want to perform layer 7 inspection on firewall, so that is part of control path, because after session management path, like after routing table, ACL and NAT, maybe you want to inspect the inspection. So inspection is actually part of the control path. Okay, so that is part of control path, where device inspect the layer 7 traffic. Maybe you want to control the, for an example, we want to control the telnet traffic, right? So like I want only one TCP connection through it. So these things I can do with the help of inspection. Okay, and then next is, guys, what is next? Next is fast path actually. Okay, so fast path is actually when device create the connection table. So that means when traffic pass through the connection table, when traffic pass through the connection table, because for the first time device have to check everything, and after that device create entry into the connection table. And once traffic is passed through the device maintain the connection table, and next time without checking ACL, NAT and anything, device can forward the traffic through the connection table directly. So that is fast path. Okay, so let's suppose here we have ASA, (10.10), 20.10, inside, outside. Okay, so the traffic is coming from 10.1 user on a random port number and going to 20.2 on port number 23. So this is our TCP traffic, right? So that traffic is going through the firewall. So whenever firewall is receiving first time on this interface, so firewall always checks the connection table first. But if traffic is for the first time, then firewall will not get any entry here. Firewall now going to check the routing table for destination route, destination IP. Destination IP is 20.2, which belongs to the outside interface. Okay, and that is your exit interface now according to firewall. So firewall going to check, okay, is there any ACL or not? Okay, and after that maybe firewall check NAT or inspection. I will discuss about NAT actually, where firewall going to check NAT. Okay, and after that firewall going to check the inspection, like do I need to perform the inspection or not. So whenever these all things checked by the firewall, so these both are actually your session management. Okay, session management plus control path. This is session management plus control path, guys. Why? Because session management check routing table, ACL, NAT, okay, and inspection is going to check in your control path. So whenever these two paths create your entry into which table? Into connection table. Okay, so once traffic is going to forward, so firewall maintain the connection table, and connection table have now entry, like the traffic is going to the outside interface, going on outside interface to this IP on port number 23, and coming from inside from IP 10.1.1.1 on port number this, and traffic belongs to TCP. So this entry exists into connection table. Now if the same traffic is coming for second time, so this time firewall is not going to check connection, routing, ACL and NAT. So it will just check the connection table and forward the directly. So that is now my fast path. That is my fast path. So fast path is actually combination of session management path and control path. Guys, are you getting my point?
So connection table, what is the time limit for the connection table, sir? I mean, how many days does it store the data?
Actually connection table have timer. Normally connection table is for live traffic which is going through. If your connection is closed, so at the same moment connection table erase the entry. Okay, so
Okay.
normally it have
Got
timers, like if I have NAT or on our device. Vicky, if you are asking about SLP, if I use ACL, SLP will override. So that's why I'm not talking about SLP here. Because if you remember, if I put ACL on this interface, so SLP is not going to be checked anymore. But if ACL is not there, then SLP is going to be checked. Okay. But in upcoming classes, you will see we are not talking about SLP anymore, because we will use multiple things. But in normal case, if you don't have ACL or NAT or something, then there is SLP. But if you have ACL or NAT, then there is no SLP. Okay. I think this is
Sir,
clear.
inspection will be happen from L2 to L7. In
Sorry.
inspection will be happen from layer 2 to layer 7.
Actually, inspection is for layer 7 traffic, because normally firewall checks layer 3 and layer 4 traffic. But for layer
Okay.
7, for deep packet inspection, we need to use policies, like for telnet traffic. I want to say I can use only one telnet connection through the firewall, so that I can limit. So that means I am limiting layer 7 traffic with this, because normally firewall checks layer 3 and layer 4 traffic, there is no problem. But I'm talking about layer 7 specifically. So inspection is always for layer 7. Like you want to inspect some UDP traffic, which is like DNS layer 7 traffic. Okay, maybe you want to inspect some application YouTube traffic, Insta traffic, so this is also layer 7 for me. So I'm talking about that type of traffic, because normally firewall do layer 3 and layer 4 on the basis of IP address and port numbers, that firewall do by default, right? But firewall added a feature later for layer 7 inspection, because if firewall can filter traffic for IP and port number for me, but now I want to filter traffic for layer 7, like application specific, like I want to filter YouTube traffic, right? Because nowadays we have to limit a lot of traffic which is passing through the firewall. So such applications like YouTube is consuming more traffic, right? Maybe Insta is consuming more traffic, maybe WhatsApp also, Facebook also. So these are unwanted application for me, so I'm going to restrict these things. So firewall also can limit such type of things, like on WhatsApp you can do chat but you can't do video call. So that is layer 7 inspection for me. Okay. Okay guys, I think this is clear. So let me show you some commands for ASP. Actually ASP can tell you if there is any type of traffic is dropping, like it can tell type of traffic, not the specific IP and all. Okay, so let's start. Okay guys, so let me show you. So as I told you, ASA maintain the ASP table. So ASP table also maintain like routing table. One routing table ASA have itself, like show route. If you check, it have routing table, right? But if you check similar show ASP table routing, so it maintain its own routing table which is created from this routing table, like duplicate copy of this routing table just for the fast path, right? And you can see it have all the informations. Wait, yeah, you can see. So we have here entry show ASP routing table, and these are the interfaces and some broadcast address, layer 3 addresses, okay, inside interface, and some other routes as well, right? So we have these entries. So these are maintained in the ASP. So if you want to check like why ASA is drop your traffic, and you can check show ASP drop as well. So it will give you the reason why the traffic is dropped. So you can check the flow is denied by configured rules and connection limit reached. Last time we tried, if you remember, we created here one inspection for TCP traffic, telnet traffic, one telnet connection only, but we tried multiple. And okay, so if we check, and if I want to drop some traffic, maybe I have already ACL here, just to check me. Actually we created some object groups, if you remember, in the last time. So we have multiple ACLs, right? So these ACLs, like 1 loopback is going for 222 for telnet, and for port number 80 only. So if I try to do telnet from this IP, from the 10.1 IP, maybe that will drop, but it will give me the reason only, it will not give me the idea who dropped that, right? Okay, so let me try to send data from R1 and telnet, maybe that will drop 20.1.1.2. so you can see the connection is refused here. And now we can check why the traffic is dropping. So the command is show ASP drop on firewall, and it will give you the multiple reasons, and in real environment even you can't try this command, okay, because you will get a lot of output. Okay, so there will be a lot of output with this command on firewall, show ASP drop, why the traffic is dropping. But you can check if you want, okay, because like you can see how many traffic it's dropped, 70 and 15 because of connection limit, okay. So that how we can check. So that is actually giving you fast path and even giving you the reason why the traffic is getting dropped, but it will never give you the IP addresses for this IP the traffic is dropped. So that is not possible on firewall. but you need to know what is fast path, slow path, and what is the control path, guys. Okay, so like there are more things if you want to know about ASP. So I guess there is some more reasons if you want to know in detail. I checked some document, but let me try if I get that document again. Wait. Yeah, wait a minute. IP block. Actually this is giving the traffic flow. I'm not looking for that. Yeah, the packet tracer command which we discussed yesterday. So the same you can use, right? Allow capture the packet tracer simple output. This is the final result if you remember. This is actually GUI of the firepower, the FMC device. We will discuss about this after the firewall, but my main goal was about to show you the drop reasons of. Let me check. Yeah, like if you get this type of drops like ACL drop, you can see, so the flow is denied by the configuration rule. So there can be configuration rule like ACL configured on the interface, ACL configured for AAA denied the box, right? So you will get multiple reasons, right? So for ACL these can be reasons, okay, like through box traffic arriving at management port only, okay, and unencrypted traffic arriving on a IPsec enabled interface. So these can be the syslog IDs in that case. If you are getting this error, so that means there can be other reasons, okay, like this event only happens when the system is in the transit state, such as system is booting or snot, engine is maybe not working, or maybe the engine is down, right? So that can be the reason, or there will be even no syslog if you are getting this one. So that means uh, so there can be like 1,000 reasons. So you can get through the document what is the reason, and you can check, like you have maybe bad IPsec NAT, right? So analyze the traffic to determine the source of the NAT T traffic. So what is actually NAT T, we will discuss about that also. So NAT T is a feature of the NAT device through that they pass the traffic. Like I will talk about that at the time of VPN and NAT, when we talk about VPN and NAT together. So that time we will discuss. So this topic will come with VPN, okay? So there can be bad IPsec port. So there can be more reason about IPsec is not authentication header or ESP. So for troubleshooting you can get the help, you can get the reason if this is the problem. So through document you get to know, okay, the reason is belong to this, okay. So these are the things. So there can be thousands of reasons like this if you go through the document, guys, okay. So just get in the chat box so you can use this document, okay. So is there any doubt, guys, regarding this? What is ASP? Guys, if you have any doubt, please let me know. Daniel, Kenel, Sahir, Siva, Vicky,
No, it's
Vicky
fine. It's
Chopra,
okay.
Vidya. Okay. Actually, these are the features. We are just talking on Cisco traditional firewall. But these firewalls also help to understand the next generation firewall, because next generation firewall is enhanced version, but still the troubleshooting remain on the CLI of the device. If you check, if you go on any tech call, so they always check from the CLI, because the troubleshooting is always done from the CLI. But maybe the packet capturing or packet monitoring you can do with the GUI of the device, but the basics things or some advanced things you want to do, that is through CLI always. Okay, so you need to know these commands. These commands are also going to be used on next generation firewall also. Okay, so if this is clear, so we can discuss one point that you must know. Like, we always use this thing for troubleshooting our network, and that is Traceroute. That is Traceroute, guys, right? So what is Traceroute? First of all, what do you know about this feature?
It gives the path from the source to the destination.
Okay, and
In
how
30 hours.
Traceroute is working, like how it's generate the traffic, and what type of traffic it's sending, and what type of traffic it's receiving back. Okay, so like Traceroute is actually to trace the path where from where the traffic is passing through, right? So this is utility command which is used to trace the path of traffic from where the traffic is passing, right? Okay, so Traceroute is actually using two type of traffic. So when any user is doing Traceroute from the device, okay, Traceroute from the device, so the packets are UDP based. Whenever user is sending data, so packets are UDP based. Okay, with some specific port numbers. Okay, but when traffic is coming back from the network devices, so those are ICMP based packets. So that means you are sending UDP based packet and you will receive ICMP based packet in reverse. Okay, so that means if you allow Traceroute, because UDP traffic is inspected by ASA by default, because if I do Traceroute, firewall will not allow that. Why? Try to understand. I have here firewall in my network. Okay, so the firewall is passing the traffic. Firewall is passing the traffic which is UDP based, and as we know, for UDP based firewall always do the inspection of that traffic. Okay, so we have entry into which table, guys? Connection table. In which table? Okay, so entry is always in connection table, but when traffic is going and coming back, that traffic is ICMP. But connection table have entry of which traffic, guys? UDP. So how ASA can inspect that traffic back with your connection table? Because connection table have other traffic, and traffic is coming with ICMP now, so traffic is not going to be matched with the same protocol, right? So there is problem. Okay, so now let me tell you the flow of the trace route. Okay,
So if firewall is blocking, then we get.
yeah, you will not
Uh,
get the trace route. If you want to see, let me show you, or I can show you later about it. So just I need to remove everything. Clear, configure, access group, clear, configure, configure, access list. I'm sure on service policy. Do we have policy? We don't have policy. Okay. So now let me logging enable, logging console 7. Okay. So now if I'm trying to do traceroute from this, so the traffic is coming on firewall now, but you can see traffic is going UDP based for 20.2, okay, on this port number, and from 10.1, okay, but inbound traffic is ICMP when traffic is coming from 20.2, from 20.2, and destination is this, so that traffic is denied, that traffic is, guys, denied. Okay, so we need to configure some policies, or you can say some configuration, so we can do trace route. But before that I want to explain the traffic flow, so you will get what we need to do for this traffic. Okay, what we need to configure. So in this example we have PC, we have one router, we have router 2, and here is the server. Okay, so 10.1 is this, 10.10, and 20.2. okay, so whenever this device is going to do traceroute, so it will do traceroute 20.2. okay, so at the same time this PC is going to generate a UDP packet. Okay, and as we know, device can do traceroute for 30 hops. For how many hops, guys? Only 30 hops, right? And similar, for 30 hops we have 30 port numbers reserve. These are the reserve port number for traceroute. If you check 334, wait a minute, what is the range? 34, 33, 4, 6, 4. So these are the total 30 port numbers that is used for traceroute purpose. Okay, so these are reserved specifically for traceroute services. Okay, now if the device is doing the traceroute, so it will create a UDP packet, and maybe the source port number can be any random port number. Destination is like 33434. okay, source IP is 10.1, destination IP is 20.2, and it always create TTL1 for the first packet. First packet have TTL1. okay, so now the device is going to send packet to R1. So whenever R1 is going to check everything, R1 know I have to forward the traffic on this IP address, but R1 check I am receiving with TTL1. so TTL1 means if R1 receiving packet with TTL1, it's going to make the TTL 0, because router always decrement the TTL by 1, if you remember. Okay, and now router decrement the TTL, and now router get to know, okay, the TTL is 0, so I can't forward the packet to the next router. Router know the route is 20, right? So it can forward to the next router, but now it cannot forward because of TTL 0. So this router have to send back ICMP packet, and this ICMP packet is for TTL exceed. This is for TTL exceed, guys. So for TTL exceed we have specific ICMP packet. So that means whenever user is sending UDP packet in Traceroute, so they are always getting a ICMP TTL exceed packet from the first hop. So the first hop is here 10.10 and sending to 10.1. So whenever this is sending back, so you will get your first hop. This is my first hop in Traceroute, right? So now second packet will generate with second port number with one more TTL with it. So now again UDP packet, this is the port number, and now second port number is 435. Okay, this one again source IP 10.1, destination is 20.2, but this time it will increment the TTL by 2. So this packet is going to send now R1. So R1 is going to check it and decrement the TTL by 1. So now TTL will be 1. And when traffic is coming to R2, R2 is also going to check everything. But here TTL will become again 0. Why? Because R1 decrement the TTL from 2 to 1, and it's going to decrement 1 to 0. Okay. So R2 have to send back this packet. So R2 have maybe IP like just for now 23.2. Okay, for an example. So it have to generate now again ICMP TTL exceed, okay, from 23.2 to 10.1. So second time user is getting a second hop in Traceroute. So first hop is 10.10, second hop is 23.2. So that how you are getting hops in your Traceroute every time. Okay. So now router PC have to generate one more packet. These are the only two packets I'm talking about. So if there is something wrong, so it will complete all 30 hops. So every time it will increase the port number, and every time it will increase the TTL number until it's receiving the actual device. So actual device is this one in our example. So this time now again UDP traffic with maybe same random port number, and now the port number is 36, the third port number, 10.1, 20.2, and TTL is 3 this time. Okay. So now packet is coming to R1. So R1 decrement the TTL by 1. So 3 to 2. The TTL will become 2, right? And now R2 is receiving the packet, same UDP packet. So it will decrement TTL from 2 to 1. And now server is here, the final device. So when server is receiving, okay, the traffic is for me. Okay. And traffic is for which port number, guys? 33436. So this port number actually don't have any service. This don't have any service, because service is like, if I'm talking about port number 23, so that have telnet service, right? Okay. If I talk about port number 22, that have SSH service. If I talk about port number 80, that have HTTPS. But these port numbers are reserved for just Traceroute. So there is no specific application or service with this port number. So this server will say, I have received your packet, that was for me, but actually I don't use any service for this port number. So for this, server generate here another ICMP packet, another ICMP packet that is unreachable. That is unreachable. Unreachable means this service is unreachable. So when 10.1 is receiving, like source is 20.2, destination is 10.1. So when 10.1 host is receiving ICMP packet with unreachable, so host get to know my packet is transmitted to the actual host. My packet is transmitted to actual host in Traceroute, because Traceroute ports are reserved. So there is no service. If there is no service, end user will generate ICMP unreachable. Unreachable means there is no service for this port number that you are looking, and from this packet the user will understand, okay, my data is forwarded to the last user. So that how your Traceroute is going to be complete. Is that clear to everyone, guys? Okay, I think this is very simple. UDP and ICMP packets. So in every UDP packet they increase the port number and also the TTL, right? and the normal device and ICMP TTL exceed, right, when TTL is 0, and the last user who received the packet, that generates the unreachable packet. Okay. Okay, so now let me show you this thing on Firewall. So this is very easy, guys. Okay, so in last class we created the object group, so similar we are going to be use the same object groups. Just a minute. Okay, so now the first thing, Firewall never show itself in the traceroute. Why? Because Firewall is the security appliance, but if you want you can do that. Okay, but for security reasons it never show you in hop count. So what do we have to do? So normally the first thing, we need to match the traceroute port numbers, or just you can allow the ICMP packets, because we are not receiving ICMP packet from outside to inside, right? Because UDP packets are matched and there is everything. But you can do both things if you want, otherwise both are not required. Just create an ACL for outside interface and match the specific. Okay, so what I'm going to do, I'm going to match both things so we can see clearly. So just I'm going to create the object group, okay, as we created yesterday for services, and that is trace. Okay, just a minute, I need to stop the logs. Okay, and now we can define here services, service object. We can define the UDP port number as our destination port numbers, right? And we need to define the range actually, 33434 to 33464, right? So this is the range. Okay, so we define the object UDP destination range from this to 33464. Okay, and the second thing, we defined that, and now we need to apply that on my inside interface just to check. Okay, otherwise this is not required. UDP packets are not required to be matched in object group and to do the inspection, but for our practice we are trying it. Okay, because UDP packets are inspected by default. Just you have to allow the traffic which is hitting on the outside interface, the ICMP packets. Okay, but let me do that. Access list, I need to create an access list. Okay, and we can give the access list name is rule 1. Okay, and we have to permit the traffic is we can't define the UDP, we need to define the object group, and object group name is trace, because we defined services inside it. Okay, and now we can define any. Okay, because there can be anyone from LAN, and now you need to apply this in the ingress interface. Wait a minute, define the name first. So we applied on the inside interface here. Okay, so this is for just UDP traffic. Now we are talking about the ICMP traffic, so we need to define object group for services. No, it's not services actually, guys. If you check here, we have separate for ICMP, for network, for protocol, for service. Okay, so we need to type for ICMP, that is ICMP, and here we can match the traffic ICMP object, and one first packet is time exceed, right, the TTL exceed, and second is ICMP unreachable. Okay, so we matched both packets. So the time exceed for the middle devices, and this is for the last device where we want to trace route. And now we have to create one more access list that is for outside, that is rule 2 for me. Okay, and we need to define here permit anyone is coming from outside. Wait, I need to define the protocol type. Okay, any and here we can define the group name. Okay, object group, and the name is ICMP. So now apply it. Name is rule 2, right? In interface outside, so we are applying on outside interface, direction remain in. Okay, so that's how we apply it. If you want to check, show history. So in history you can check we created the object service for traceroute packets, UDP packets with their port number. Then we created the access list for the same and deployed on inside interface in direction. Okay, and similar we created for ICMP packets. Okay, time exceed and unreachable, and create ACL for the same and applied on outside interface, direction in, because the traffic is coming, right? Because if you remember, if traffic is coming on interface and ACL is here, so SLP will not check in that case, if you remember that. Okay, so that will override the SLP. Now if you want to trace route, guys, so let me check. Wait, maybe the trace route is done. So you can see the trace route is done. It's not showing the firewall because of security device, but if I do that and we have enabled the logs here, so you can check. Come on, what's wrong now? Deny UDP. It's going to deny. Or maybe there is some DNS traffic, I don't know why, but it must allow the UDP connection. You can see that this is allowed. You can see this packet, right? With this port number, right? And ICMP connection is checked for the same, right? If you check, so the traffic is coming, right? So that's how we can do the trace route. I hope this is clear to everyone.
Yeah, it's okay.
Okay, so that how you can yeah, you need to enable this feature during the production environment also. So you have to specify some policy on for this interface also, and that is enough. Only this is enough for outside interface, but make sure there should be no any attacks in your network because of this policy only. That is enough. If you avoid the upper one, no problem, but if you have some specific policy already here, so you need to permit that traffic in that case. If everything is allowed from LAN interface already, then you no need to allow this. Okay, but on outside interface you need to allow this, the ICMP packets. Okay, so I think we discussed only two small topics, but those are very important from interview and even from the production environment, right? When you are going to troubleshoot. So if you know the packet flow and you know what is ASP, then you can easily troubleshoot the things and you will get what is the reason, right, why the traffic is dropping. So you can simply check. Okay, see, ACL is dropping more and more traffic, but it's not showing which traffic is dropped. That is not possible to check here. But on latest firewall, the next generation firewall, you have graphical user interface and you will see the logs directly, so that is more easy for you. Okay, So I think that's enough for today. So in tomorrow class we are starting with net. Okay, so we will discuss about net first today. Okay, so we are almost now on the same pace where we finished the last few classes, because we finished with net classes if you remember, and then we start again the classes, right? So
Yes,
I
yes.
want you to everyone
Yeah.
join the next sessions, those are very important for you. Okay, and you can tell me your doubts, you can put your doubts in the group as well. When I will be available for text, I will give you the answer, the reply. Okay, or even you can help each other in the group also if you know, so that will be better for you also. Okay.